Okay, so let's start our lecture today. So, okay, yeah. So we need to find some way to compute the limit of this guy. So, okay, I feel like we can't. Find a real value function. Okay, so I think I may need to ask for some help right now. So, let's see. So. Okay, so I have a question here. So okay, let me use the model. Okay, okay, so okay, so basically I'm studying the wire stress sigma function being defined as z times the product of omega not equal to 0, 1 minus z over omega e to the z over omega plus 1/2 z times z over omega square, the fraction z over omega square. So, and then, so what I do is that I'm breaking this omega z, sigma z, sorry, I'm breaking this sigma z into two parts. So one part that corresponds to an even sum, even product, where the product is the previous part. Like, so first I give an enumeration of these omega i's, and then I'm defining the fnz to be the product of I from 1 to n, 1 minus z over omega I. And I'm defining the rest function, which is the product of the exponentials, to be e to the sum I from 1 to n z over omega I plus 1/2 z over omega I squared. Okay. And then what happened is that it is a fraction z over omega I squared. Okay, and then I'm trying to show that this fnz and gnz converge locally uniformly on any compact subset k. Okay, so what I do is that for fnz, what I do is that so it is an infinite product. So basically, I'm using a property that the product an the product converges. An converges if and only if the sum of the log of the an, where an is just a sequence of points, converges. Given that there is a log function that's an is defined on the log function, and also the log of 1 is equal to 0, the branch of log, right? So so why take because I showed that there is a log function that can be defined. So basically just taking the space separating line to be the space separating ray for the log to be the log to the to be a line that avoids all the z over omega i's. Sorry, avoid all the 1 minus z over omega i's. So assume that this z is not equal to any of the lattice point. Okay. So in that way, I was stuck on how to so how can I really show that the infinite sums of the log, the log of yeah, so basically for the log, you want to show the log convergence on this compact set. So basically what I do is that I want to use the M test. So basically I want to find an upper bound for these modulus of the capital log of 1 minus z over omega I. That and show that the upper bound is actually summable. So however, so because the capital log basically is given as the real log plus the argument, right? But however, I think somehow I know that this real log and the argument, they both approach to 0, because lattice point under that enumeration, right? So under the enumeration is given by the circle enumeration, right? So basically, from like starting from the inside lattice point and then spiraling around and go outside. So basically, yeah. So basically, I separate it into 2 parts. So maybe I want to show that the real log of the modulus of 1 minus z over omega I is summable. So I try like using like a ratio test for these sums, but somehow I get stuck on how to evaluate the limit of n plus 1 over an. So basically, I can't use L'Hopital's rule because it is like a 2-dimensional object and then it's also discrete. So so do you have any idea on these problems that can help me solve the convergence problem for the log? Thank you. Okay, so okay, so oh, okay, okay, okay. So well, I'll let the GPU work on this one. Help me answer this question. So maybe let's think about how should we approach to this GNZ, right? So okay, so this GNZ basically it is a exponential of some let's see. So yeah, so this GNZ is just the exponential of an infinite sum, right? So is there anything that we can use to help us determine the convergence behavior of this GNZ? So let me erase this part. Okay, so the question is that, is there anything that can help me analyze I think if I show the exponentials converges pointwise, right? Because the exponential function is always continuous, right? So if I show the exponents converges, then by the continuity, right? So this one has to converge to the limit function. Okay. So okay, so let's state our strategy here. So for the GNZ, right? So we aim to show yeah. So the question is that is this function really convergent, right? To show the convergence of the sum. So yeah, I kind of think that it is converging. So let's see. So okay, so so can we use the M's test for this one? So so let's say so can we find a okay, so our aim is to find a maybe let's say using M test. So let's aim for find a summable upper bound So for each n, find some upper bound for the modulus. Let's say maybe for each I, okay. Z over omega I plus 1/2 Z over omega I squared. Okay, so I think maybe I'll just stop here today. So I'll continue next time.